Hi, today we'll be coding this cube where each of the faces is a square grid of square tiles, and a cube has 6 faces, but in this case we never see the bottom one. So we'll be creating 5 face elements. One more thing, along each edge, whether it's horizontal or vertical, we have 7 tiles. So that's what we start from. The number of faces we generate is going to be 5. So we have our cube element, and within it a loop for let I going from 0 all the way up to p, increment this I, and create our face elements. Next step, I said we're going to have n equals 7 tiles along each edge, and for a face we're going to have n times n. So the number of tiles per face is going to be n times n. This means we're going to have a similar loop inside every face element. This one is going to go up to m. And we're going to have a different loop index, of course, and then our tile elements. And one more thing before moving on to the CSS, here in a style attribute, we'll be passing the number of tiles per edge to the CSS as a custom property. Now, what this does, if we change this number n right here, obviously it changes n, it changes m, and it changes the number of tiles per face, but it also changes this value right here. And this is how the CSS knows how many tiles we have per edge, and this is a value that it uses to style things. So if we change n right here, we don't need to make any changes to the CSS. The CSS adapts because it uses this custom property. Now, moving on to styling. Here, we'll be setting a tile edge length, let's say 2 And if you've seen my previous videos, you know this part. On the body and on all div elements, set display grid. Next, on the face elements, we'll be setting a grid template. So for the rows, we're going to have repeat, and we're going to have n rows, each with a height equal to that edge length. And then for the columns, it's going to be the same, n columns, each with a width equal to that tile edge length. Now let's see the tiles. So tile, we'll be setting box shadow, 0 offsets, we're going to set a blur, and we're also going to set a spread. So like this, let's see it. Okay, good. Now we're going to want the faces to be stacked one on top of the other. And we do that by placing them in the same cell at the intersection between the first row and first column. So basically the cube is a grid with a single cell, 1 row, 1 column, at their intersection there's 1 cell. So grid area, first row, first column. Now we want to put everything in the middle, so cube, place self, center. It only looks in the middle horizontally, but it is in the middle vertically as well, and that's because the body currently takes the height of its content. So we need to force it to take the full viewport height. So height, let's see it. Okay, this gives us that ugly scroll bar, and that's because we have a margin on the body, so let's reset that. Or we could just go full nuclear and set overflow hidden. Now, we're just going to collapse the body for now. And one thing we want to set for all divs is transform style preserve 3D. This allows all the children of 3D transformed elements to also be transformed in 3D. Because otherwise, if we transform just the cube in 3D, then the face and the tile elements are not going to be in 3D, even if we set them to be in 3D with a 3D transform. They're just going to get automatically flattened in the plane of their cube parent for the faces, ancestor for the tiles, whatever. So let's start setting some transforms. So first off, let's set here a rotate x, let's say, minus 35 degrees, rotate y minus 45 degrees. So like that. Now here for the faces, we're going to have another 3D transform. this is going to be rotate 3D, and the vector components along the x-axis I, along the y-axis j. Then along the third direction we're going to have always 0, so we just set it like that, we don't need a custom property. Then the angle is going to be a factor f, which is going to fall back to 1 times 90 degrees, and then we're going to translate by half a face edge length. Now half a face edge length is going to be half of the number of rows or columns n times the tile edge length. So that's going to be calc half 0.5 times n times the tile edge length. Now of course we need to set I and j. Initially I is going to be 0, and we want j to be basically its complement. So when I is 0 we want j to be 1, and when I is 1 we want j to be 0. So that's going to be j, yeah, if I could type 1 minus I. Now for the last face, which is basically the top face, so last child, here we'll be setting I to 1, and this makes j 0. So if I is 0, then that means rotate 3D 0, 1, 0, so that's a rotate y. And if I is 1, this means we have 1, 0, 0, so that's a rotate x, rotate along the x-axis. Okay, now we need to set this factor for the lateral faces as well. So here, in a style attribute, actually, we're only going to set this if I is smaller than p minus 1. We'll be setting the factor to the loop index I, otherwise we don't have a style at all. Okay, now let's say we don't want to see the back of those faces, so hidden, sorry. Now let's collapse the cube and the face elements, and let's focus on animating those tiles, so scaling them and yeah, moving them inwards. So we're going to have a scaling factor, let's say 0.2, an animation duration 2 seconds, let's say, and now keyframes, transform, scale, the scaling factor, let's say here we're going to have the animation name as well, make it ease in out, infinite, alternate. Let's see it. Okay, it's starting to look like something. We also want to move them inwards such that they always touch along the cube edge. So that means moving them inwards by half of what's left of the edge after scaling, and half because it's half on one side and half on the other side. So what's left after scaling? So after scaling, the edge length becomes the scaling factor times the edge length, and what's left on the sides is half of the edge length minus the edge length after scaling. So that's what's left in total is going to be the edge length minus the edge length after scaling. So L minus the scaling factor times L. So that's basically 1 minus the scaling factor, everything multiplied with L, and we want to translate by half of that. So, and inwards, so it's going to be with a minus. So minus 0.5 times 1 minus the scaling factor times the edge length. Okay, and we can bring that minus inside, and that's going to change the signs of those two terms. Let's see it. Okay, but we're going to want to have a delay, and that's going to depend on the column and the row that each tile is situated on. Let's set those as custom properties right here. So we're going to take this loop line, and in a style element we'll be setting, this is going to go up to n, right? So we're going to have tile nth child every n elements, every n tiles. We're going to have, so here we're going to set the column index or the horizontal index, so along the x-axis, x, we're setting it to the loop index, and then we're going to have something very similar along the other direction, so the vertical direction along the rows, so that's going to be y. So we're now going to have every n tiles, we're going to have after the previous tiles, after all the previous tiles. So okay, and of course we have +1 there because nth child index is 1 based as opposed to loop index, which is 0 based. Now, having done this, we're going to compute a middle index. So this is going to be calc. So it's the average between the first index, which is 0, and the last one, which is n minus 1. So that's going to be 0.5 times the sum, which is going to be n minus 1 plus 0, which, yeah. So then we're going to compute the absolute value of the difference between this middle index and the current index, both along the columns and along the rows for the current tile. So horizontally along the x-axis, we are going to have m minus x, and then minus this one is going to be basically those two values flipped. Now we're going to take this and modify it for the other direction, for the y direction, and then we're going to compute a delay. So an animation delay, this is going to be calc. We're going to have something inside those parentheses, and we're going to multiply this with the animation duration. So first we're only going to take the option where the top face, where we have the top face. So that's going to be I, because I is 1 for the top face, if you remember. So last child, I is 1, for all the others I is 0. So this part only applies to the top face. And we're going to have, so those two absolute values, and these go between 0 and m, so their minimum value is 0 and their maximum value is m. And everything over m, right? Now let's put those all between parentheses, and let's see it. So it starts off a bit too slow, and it kind of makes sense because these two, their maximum value can be 2m. So let's say that we're just going to divide by half, so 0.5, and of course the animation starts a bit later for some, so let's say we're going to subtract 1. Okay, this looks much better. Now let's take care of the others. So we're going to have something similar for J times. Now here, we don't want to go from the middle vertically. We want to go from the top, only from the top vertically. So we're not going to have dy, we're going to have y there. And we're going to need to have a delay, which is going to be maximum like that. So as you can see, this works. But again, we get over 1, so 1 doesn't suffice. So we're going to subtract 2 from there, because the sum of these over m, even if we divide it by 2, is just going to be bigger than 1. So that's the whole deal there. Now let's start prettifying stuff. We're going to set border radius 5 pixels. For example, there we're going to set a color, magenta or something. Okay. We're going to set a background. It's going to be pretty dark, but not quite black. Okay. Here on the body, we're also going to set a background, and it's going to be a bit lighter. Okay, and I think I want to make this a bit faster. Let's see it. Okay, this looks much better like this. Okay, and we're going to want to have another animation, and this is going to animate the color. Let's say aqua. Okay, so we're going to have a second animation. Actually, what we can do is set infinite alternate, so we want them both to be infinite and alternate. Animation name, animation duration, okay, so here we're going to also have that delay, right? Okay, and finally animation timing function, ease in out linear. Let's see it. Okay, now let's do something nicer about this box shadow, right? And we're going to have a first shadow. Let's see that. And then we're going to have a second shadow similar to this one, except we're going to have a different blur and a different spread radius, and we're going to use a semi-transparent white right here, so something like that. So what we'll be having here, inset the first shadow, right? And now we'll be taking this, and then we're going to modify. Let's see it. Okay, it's starting to look nicer. Now we also want an animation on the cube, so let's move on to that. Let's collapse the tile, collapse those keyframes, and let's move on to the cube. So here we're going to have that rotation. Let's say we're going to want to have a translation first. So translate Y. So something like this, and here we're going to have another custom property, and we're going to register these custom properties. So property, here we're going to have syntax. This is basically the type, so length percentage, initial value, let's say 0%, inherits, not necessary, so false. Now we'll be taking this and we're going to use it for the angle. That's going to be angle. Initial value is going to be, let's say, that minus 45 degrees. I think we can collapse these as well. And here we're going to have keyframes. So to, let's say, something like this, 1/8, and then we're going to have, actually could have just copy pasted that, right? So, and here we can have 45 degrees. Now here we can have animation, the animation duration, ease in out, infinite alternate, so it just oscillates up and down. Let's see it. Okay, and we're also going to want to have that rotation, and let's say that this is going to be a bit bigger. Ease in out, infinite, let's see it. Okay, now the thing is, the way we're doing things here, we are never seeing one of the faces in the back. So something we could do, for example, I'm thinking we can get rid of one more face. So let's make this 4. Okay, and let's make this minus 135, so right, like this. And this is going to go up to minus 45. So like that. Or one more thing that we could do, I'm not really sure this is going to work, but it's a pretty interesting idea. So we can have another component here. Let's say, actually we can use a Q factor. So property Q, and this is going to be syntax, right? So initial volume 0, inherits false. Of course, none of these need to inherit. And here we can have a calc. All right, so can have this. times 90 degrees, right? And we're going to have these Q keyframes. And this is going to change to 1, oh sorry, Q, at 50%. So we're going to have Q, and it's going to have the same animation duration as this one, except it's going to be steps 1, infinite. Let's see it. Okay, now the real test is here. If we decrease the number of cube faces, the number of cube face elements. Okay, now the thing is, yeah, okay, so we are going to change once more. We're going to go from -45 right here. We're going to go to 45. Let's see it. Okay, so now we are doing it with 3 face elements. So we've really reduced the number of elements, and that usually really helps with performance in these demos where there are a lot of elements. So let's see, we have 7 times 7 for each cube face, and we have 3 cube faces. That's 150, but initially we had 5, so that's 250. So that's basically, that's quite a big reduction, of 40% reduction in the number of elements. So that's quite big, and it should help, especially on some machines. So yeah, this is it. This is what I want to show you for today. I hope you've enjoyed this video, and if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or you can get me something off my Amazon wishlist, or there's the possibility of a one-time donation. In any event, the links for everything are going to be in the description, for this demo, for my Patreon, for my Amazon wishlists, for everything basically. Or you can at least share this to show the world what can be done with CSS these days, because honestly I think it's pretty damn cool. In any event, thanks for watching, and until next time, bye!